How's it going? Let's do some physics. So before we get into formulas and math, let's go over the concepts that we have to understand about this problem. So the fish that are swimming in the seawater are going to experience the sound from this backfire at a different time than the people in the boat who are experiencing it in the air. So why is that? Well, the speed of sound is different depending on what state of matter it's traveling in. Sound waves are created by vibrating atoms. So sound will travel the fastest through high density states where there's more atoms closer together, the vibrations are more likely to happen. When you take those particles and you separate them further apart, getting into a liquid and then even further getting into a gas, particles are very separated from each other, so there's less of a chance that they'll be vibrated. Okay? So the speed of sound actually will be the fastest through a solid, it'll be the second fastest through a liquid, and it'll be the slowest through gases, also known as air. This is why back in the day when you played telephone, you couldn't hear the whisper to your friend, but when you spoke through the string being a solid, the sound traveled through a lot easier. Okay? Not only easier, but even faster as well. So, let's go over the math involved behind answering or calculating the time that the fish experienced the sound from this backfire and the time that the fisherman experienced the sound from this backfire. All right. So part A, what we need to do is we need to figure out this backfire happens 1.55 kilometers away, which to keep MKS units, we're going to write as 1,550 meters. Okay. So we're given that the backfire happens 1,550 meters away from the tuna. You can look up that the speed of sound in salt water is 1,560 meters per second. And then the question is, how much time does it take this sound to travel the distance 1,550 meters per second at that velocity? Okay? So luckily from kinematics, we have this lovely formula. Distance equals velocity multiplied by time. So this is a formula that ties together our two knowns given to us in the problem and looked up in a table, and our unknown, which is time. So we take this formula, we rearrange it so that it solves for time. We do that by canceling out the v, by dividing it here and dividing it here. That will give us d over v equals time. So this is the formula we need to use to figure out how much time it takes the sound of the backfire to reach the tuna. Okay. So let's write down the values that we know in order to figure this out. And let's go on to a nice clean page. So write down everything now so that you have it. Okay. All right, so plugging in our numbers into the formula we're going to use for part A, which remember was time is equal to the distance the sound happens, how far away the sound happens, divided by the velocity that the sound travels. Okay? So the time it takes these tuna that are swimming in the seawater to hear the sound is going to be this. Remember, the distance was 1.55 kilometers away. The speed of sound through water is 1,560 meters per second. When you divide these two numbers, you get an answer of around 0.994 seconds. All right. So since we're rounding to three significant digits, we're going to put the approximately symbol. All right, so that's around the time it takes the tuna to hear the sound. So in part B, what we're going to do is we're going to calculate how much time it takes the fishermen to hear the sound. Remember that the fishermen are in the air where sound travels slower. So we should expect in part B for the time to be more. So since it's traveling slower in the air, it's going to take more time for the sound to hit the fishermen. So let's figure out exactly what that number is in part B. All right, so since we're solving the same exact question, and since we are solving with the same distance away, D is going to be the same in part B, and the formula is going to be the same because we're solving the same thing and the sound happens the same distance away. So time is going to be equal to distance over velocity. So the fishermen are the same distance away from the sound as the tuna. So we're going to keep the distance the same. And remember, the speed of sound in air is actually different than it would be in seawater. The speed of sound in air is 343 meters per second. Remember, this is a number that you can look up. It's a tabulated value. So that's how you get it. So after you take 1,550 meters and you divide it by 343 meters per second, you'll get the number 4.518 and then some decimals. Rounding this to three significant figures, you would have t is approximately 4.52 seconds. All right. So, just like we predicted, the fishermen would experience the sound way after the fish would experience it. Okay? So this is why maybe sometimes you're fishing and then out of nowhere, the fish might swim away and then you'll hear an explosion or maybe even lightning or something like that. All right? Remember, the speed of sound is the slowest in the air and it is the fastest through a solid and the second fastest through a liquid. All right? So this is why the fishermen experience the sound after the fish.